In chemical kinetics, we have the rate law that we can write down as R equal to K. For instance, we have a reaction of A forming B, then it is concentration of A power to nth. The K is the constant or the rate constant, and the N is what we call the order of the reaction. A reaction can be 0th order, can be 1st order, 2nd order, and so on and so forth. The unit of R is always molarity or ATM over unit of time, while the unit of concentration, of course, is always molar. So depending on the number of the order, could be any numbers, we can then determine the unit of the rate constant. So the unit of rate constant can be diverse, and this will highly depend on the order of the reaction. Generally, the order of the reaction we determine through examination and experiments. So this one we determine through experiments. We can also have multiple reactant systems. Say we have A plus B plus C forming D plus E. Normally we are looking at the order of the reactants. Now in this case, we can write the rate law to become R equal to K, A, X, B, Y, and C power to the Z value. Now in this case, in the experiments, most of the times we will be given the data of the rate and data of molarity. So say we have a table that would look something like this. We have molarity of A, and then we have also molarity of B, molarity of C, like that. And on the other end, we have the rate of the reaction. We will be given several values of A and B and C and also the rate. And by using simple ratio of the first state, for instance here, with the other state, second state, or third state, just find the easiest way that we can cancel out most of the concentrations. We then can determine the X and the Y and also the Z. For example, if we compare reaction 1 over reaction 2, so we are comparing rate 1 and rate 2, the K can immediately cancel. We can cancel that out. And then AX, BY, and CZ. The other one will also AX, BY, and CZ as well. Now in this case, it is wise for us to compare the data where we have similarities in concentration. So say if we have several data that has same concentration of A, in this case we can cancel out A. In other case, if we also have the same concentration of C, we can also cancel out C. And then we can find the value for B in the first rate and then B for the second rate. And then through this, we can find the value of Y, as the R1 and R2 is also known in the table. The table normally we will obtain through experiments. In the case where we have multiple reactants, we also recognize the term of the total order, where, as the name suggested, we just sum up all of the order of the reactions of all of the reactants. Now, what if we have only one reactants? Therefore, we have nothing to compare to. Say we have a table of time against concentration of A over time. The concentration of A at T equal to 0 is what we call the A0, or the initial concentration of the reactants. One thing that you have to really remember is that this table has to be built based on reactant. Gaseous reaction, more often than not, the data that will be given to you is the total pressure. So first thing is that you have to build an ICF table, like in stoichiometric chapter, to make a table of time against the pressure of the reactant only. So only reactant that we will focus on. Now, how do we determine the order of this reaction? Is this 0th order? Is this first order? Is this second order? How do we tell? As we cannot use comparison between rates because we only have one reactant, unlike the cases where we have multiple reactants at the same time. So in this case, we'll discuss what we call the integrated rate laws.